Howdy everyone and welcome to our last video for topic 4. This video is on theorems, all right? So what are theorems, first of all, and then the common segment theorem, a good example theorem. So first off, theorems, as American philosopher Shaquille O'Neal says, I'm like the American theorem. Not too many people know the answer to my game. Theorems are something that we do not assume to be true, that are not self-evident and obvious to everyone at first glance, like an axiom or a postulate can be, right? These are things that are proven by a chain of reasoning that will inevitably follow from our assumptions. Inevitably meaning that there's no chance for it not to be true if you agree with our assumptions, like knocking over a domino, right? All the dominoes are going to fall over to the last one. This is that chain of reasoning. So, like Shaquille O'Neal says, not too many people will know the answer, but if they're willing to listen to you explain it, they will, right? They can follow along and get there. But it's not a guarantee that everyone already knows this to be true. That's why we prove it. This is not the same thing as a theory, to be clear. Theories are like conjectures. They're educated guesses, but they're a little stronger. They're backed up by experiments, right? Like, predicting I can't fly, and then you go test it by jumping off a roof, using an umbrella, flapping your wings, thinking really hard. None of those things make you fly. So you've tested it a bit, and you still proved that, yeah, I can't fly, but you don't know it for sure. Maybe you could fly in different circumstances, right? Like with a paraglider suit. But theories are different. These are things that must be true, right? Theorems must be true if you agree with the starting points. So let's look at a good example of a theorem, the common segment theorem, which can actually prove two different things in geometry. So the common segment theorem is that if I have the line segment AD, right, allow me to move around my thing so you can see a little better. There we go. And I'll shrink myself down here. If I have the line segment A to D, right, then I can break this down into A, B, B, C, and C, D. If I'm given that AC equals BD, right, can I prove that AB equals CD? Okay. Notice I've already highlighted the colors to make this a little easier for you, right? Look at those highlighted colors. What do we think might be the key to this? Well, and again, look at the name, the common segment theorem, right? So the common segment is going to be important here, but how? How is it going to be important? Well, let's use a two-column proof and fill it out together, right? This is going to look a little bit like some of the questions on the assessment and in the homework where I'm giving you one half of it and you need to find the other half. But notice I haven't given you any options this time. You got to figure it all out yourself. So what are the things that are going to fill out our reasons, right? Well, I'm given that AC equals BD, right? And then I'm breaking down AC into AB plus BC. And likewise, I break down BD into its two segments. And then I notice, well, I replace AC with the two segments it breaks down into. I replace BD with the two segments it breaks down into. And from there, right, I have AB equals CD. So I've removed this BC bit from both sides. So let's go through each of those steps individually. How did I get the AB plus BC equals AC? Maybe consider this, pause the video and think about it, and come back and check. I got it with the segment addition postulate. Now, notice I've added something to one side, right? Now, why is this not the addition property is what a lot of people ask. Remember, the addition property is adding the same thing to both sides. Did I add the same thing to both sides? Is there a BC over here as well? No, right? Didn't do that. What I'm saying here is AC can be broken down into AB plus BC, which is the segment addition postulate. The same thing is true for my next step, which is also the segment addition postulate, right? Because I've broken BD down into BC plus CD. So what happens next? How do I get this AB plus BC equals this BC plus CD? That is the substitution property, right? Notice that AB plus BC equals BC plus CD. And also notice I've extended outwards a little bit, the last step, to really make it clear that the BCs are removed. So I'm removing the same thing from both sides, right? What step could that be? What reason allows me to remove the same thing from both sides? That would be the subtraction property, right? Which allows me to subtract BC from both sides. So essentially what I've done is I did have a BC here, and then I subtracted BC, and likewise I had a BC over here, and I subtracted BC. Now, some people will write this out, and then they'll have a simplify step, right? But in later geometry, we won't need simplify steps. We can just follow along very quickly without the need for a simplify step. We have simplify steps on like the homework and the test and stuff to make it easier to follow along with. Okay, so that's one way of doing this. And you'll notice, what did this really fundamentally break down to? So let's rewind, right? Rewind and look back at where this all came from, right? What happened here? Well, fundamentally, what I've proven is that if two line segments overlap with each other, I can subtract the overlap and they'll stay equal if the original line segments were equal. So this is essentially segment subtraction, right? Proving that overlapping bits of segments can be subtracted and equality will not change for the remaining segment. So it's kind of like the subtraction property, but for segments. Oh, okay. What about this? Let's reverse it. What if I start with two line segments that are equal and then I add the same line segment to both, right? So to one of them, AB, I've added BC, and to the other one, CD, I've added BC. Does that mean that they will stay equal if I add the same line segment to both? Right? Knowing that they all end up on the final line A, B, C, D? Let's break this one down, but this time it's going to give us the reasons and we need to write the statements, right? So if I start with AB equals CD, right? How do I prove in the end, again, that AC will equal BD? So they want us to do the addition property of equality first. So they want us to add the same thing to both sides. What are we going to add to both sides here? Okay, maybe you pause the video to think about it. If not, try doing so now. I think we're going to add the common segment, right? We're going to add the same segment to both of them, like what we said before. So I'm going to add BC to both. Now, using the segment addition postulate, right? How am I going to use what I've added to simplify or change what I have here into a more useful form? Remember, our goal ultimately to get AC equals BD. So I want to somehow get an AC on one side of the equation and a BD on the other side of the equation. Maybe you pause the video again to consider it, but we have the segment addition postulate, which also allows us to add together two separate segments that are connected into one larger segment. So here, AB plus BC equals AC. And then BC plus CD equals BD. You see? So I have essentially clicked together my two sides into the two things I want to prove, AC and BD. So now the substitution property allows me to replace, I miswrote that. Oh, no, I didn't. See, AB plus BC got replaced with AC. In this part up here, you see, this is the trick with substitution property. A lot of people miss this, right? It doesn't have anything to do with this previous step. It has something to do with this step. AB plus BC got replaced with AC, right? But this side is staying the same. Now, in the last step, I want to replace the other side, BC plus CD, with what I know it replaces with. Allow me to move my screen again. AC equals BD, right? Because I've replaced the BC plus CD with just BD. And now I've proven it. AC equals BD. So that is a theorem. This is something we have proven to be true. And again, you will notice, right? Let's rewind. What we've essentially proven is that if I add the same line segment to two line segments, they stay equal afterwards, which is kind of like the addition property of equality, but for line segments, right? So we've essentially proven things that we probably were pretty confident we could do, right? Adding the same thing to two line segments keeps them equal, and subtracting an overlapping bit from two equal line segments still keeps them equal in length, right? So very useful properties that we have proven this time as the common segment theorem instead of assuming like we did before. All right. Hopefully this helps make a little more sense of what these kinds of geometric proofs can look like, how we use statements and reasons, how we fill them in, and how we can tell the difference between the addition postulates and the properties of equality for addition. I'll see you next time in the next topic. Please review these videos as much as necessary. Ask me any questions. The videos are unclear or not helpful, and I will be happy to help you out. Have a great day.